Hello, I am Gato Emiliano. I am the manager of the research and development team. So, what problems do we try to solve with GeneXus? The problem is, on the one hand, that more and more creating software is becoming more complex, that also we have to do it in a shorter time. Therefore, the problem that we've tried to overcome since the beginning of GeneXus is how to add value in record time, how to change the order of giving value to the different industries through software. In this book of how to solve it, which is a book that dates back to 1945, which was created to solve mathematical problems, provides us with a method to overcome problems, which in a way is one of the methods that we have been using in GeneXus over time. The first step of how to overcome any of the obstacles that you may come across is to start by understanding the underlying problematics. These may seem like obvious steps, understanding the problem, uh, and when you're doing mission critical applications, we strongly rely in on all the experience that we have as a community in GeneXus. We're exposed to different challenges from the different industries where you need to have mission critical applications, and this is why we believe that GeneXus is a great plan to overcome that. The second step is to create that plan, and that plan was GeneXus. GeneXus is a plan that was created back in the late 80s by Nicolas Rodal and Gonda, and the third step is to execute that plan ever since the 90s in the first versions until today. The third step is to execute the plan, and we are there. As a matter of fact, today we have our 18th version of GeneXus based on 5 pillars. These pillars are what Armin Bachmann told you about in his GeneXus talk about GeneXus 17, GeneXus 18. But the fourth step of how to do this is an extremely important step that we do every year in GeneXus. How could it be better? So we are very, very proud with our 18th version, but we have the challenge to try to build a better GeneXus year by year, version after version. And that is what I'm going to focus on very briefly in this presentation. How can we make a better GeneXus? What are we thinking about? And to build a better GeneXus, we need to understand the context, as I said. We need to go back to step number one and understand what it means to build a mission-critical system nowadays. So that is why we're going to go through the different technological challenges that we have when it comes to building those systems in different circumstances. And then we're going to talk a bit about how we perceive the future of systems creation. If we focus on technological challenges and we compare it to the ones that we had back in the 80s with what we have today, well, they have increased a lot in different areas. For example, UX or even security, or why not, how to store data in our systems. How do we compute our code? How do we take it to different computing forms? And finally, how do we work with IT automation in development? So, for instance, what concerns storage, you have to think about blockchain, which is changing to a great extent how we're thinking about systems for the future. Some people are talking about a back-end revolution in what you call Web3 or Web5. And certainly we will, in terms of storage, we will keep on having cloud DBMS, which are storage systems that are born in the cloud. These are not storage systems such as a DBMS that was migrated from on-premises to the cloud, or or what could be a SQL server, but they were born in the cloud. In practice, these new storage systems are innovative and they allow us to have better consistency, partition, and availability at the same time. In practice, on top of all the theoretical aspects that you could discuss. A good example of this would be, for example, SAP HANA or Google Cloud Spanner. Now, all these challenges in the different areas that we have, well, you know that behind that you have code that needs to be created. And when you think about code, oftentimes the first thing that you think about is the code of your programs, which of course you need to keep on generating. But the challenge that we have today is that more and more we will have to generate on top of the code for the programs, the code for configurations, the code for data, for example, testing data or initialization data, and also we will need to generate code, and we are working on it for infrastructure, not just for not just in terms of the code to generate the scheme and the scripts for the database, but for any element of the infrastructure. Therefore, we have a great challenge here in terms of how we can have all this code generated to look cohesive and consistent. Now, where is this code going to run? Well, at the moment, what's happening is that increasingly we're leaving on-premise systems to hybrid or cloud-based or hyperscaler systems. These are cloud providers that provide us with different innovative ways to compute what we are creating in terms of the programs that we are creating. So much so that we have already worked in serverless architectures or container-based architectures, also serverless containers, and most certainly all these platforms will keep on innovating in the way of how we compute systems in a not so distant future. Of course, we will have new ways of computing that will come from these hyperscalers around blockchain technologies. So these are things that are already happening, but more and more this will become faster and faster. And one of the things that, if I may, the software industry is falling a bit behind compared to other industries is the capacity that we have today to, when we are delivering our products, we can ensure quality. We can ensure quality from different perspectives, not just from the point of delivering a system that will compute enough, but we need to ensure quality following different non-functional requirements, such as, for example, scalability or performance, security, observability. So making software today is, in a way, having different elements and services from different suppliers. And it becomes thus essential that when we deliver a system, it should have observability that comes built in. It also needs to have built-in observability through technologies such as OpenTelemetry that is going to allow you to have a login and metrics and traceability throughout the system. But we should also be responsible for our carbon footprint and the carbon footprint of our systems. This is what we mean by quality. This poses a great challenge for the whole industry. How can we not only generate code, not just allow it to compute in different environments, but also that when you deliver it, you have a clear proof that it's meeting different quality criteria. There will be monitors for each of these features that will allow us to say, well, yes, I feel happy with the system that I'm delivering because it works according to these standards. And why should we do that? Because the experiences that we will be facing will be more and more sophisticated in the future. That's why one of the great challenges that we are going through at the moment is to incorporate different roles within our teams, in particular concerning designers. And when I say designers, I'm not talking about necessarily visual designers that will make our stuff look nice, but real designers in terms of the new interactions that will allow us to make our software remove a lot of the friction that we still have today. These designers, which are interaction designers or dialogue designers or architecture designers in our data, and needless to say, visual designers, they all need to be a part of our teams to build more sophisticated systems from the experience point of view and with less friction. Super apps, as Armin was telling you about, this is a new trend, and we've been talking about this for quite a few years. Nowadays, Gartner is saying that it's one of the main technologies that will be taking off this year. And I think that us and the whole GeneXus community is finding itself in a great place to just delve into this world much earlier than the others and with great tools. What do we think that in not such a distant future, our tools need to have these interface elements? Because we need to have a GeneXus element that can be composed in software that's not built with GeneXus and vice versa. So for that, we will stick to standards such as for web components. And we will have new interactions. This is a fact, and they are challenging us as an industry. We have interactions around augmented reality, how we can incorporate that to business systems, or VR, and so on and so forth. So these are briefly the challenges that we have in terms of the technology, and that is the context. And if I may, to a greater or a lesser extent, we can agree on this because this is evident, it's happening, we can see it, and we are already working on it from different angles in GeneXus. So what we're going to do is we're going to try to evolve in that direction. But what I think makes us stand out as a community, I think, is in terms of how we conceptualize how to build systems. As I told you before, we've been wondering how we can make GeneXus better, and we've been doing a lot of research in that sense. Sometimes to take a look into the future, you need to look back so that you won't forget, and as Brett Victor would say, so that you don't fall in the tragedy of forgetting what was good about the past. This is, in particular, a book that was very recommended that talks a bit about the whole logo language creation experience. This language, Logo, was a language for children that allowed children to start programming without really, I mean, not really programming, but they didn't really have to know anything about programming. Perhaps you remember the turtle, the well-known Logo turtle. But what comes from this is this quote that I think is critical, and we really believe in it in GeneXus, that the way in which people learn and the way in which each of us can learn greatly depends on what models we have available. So the different modeling tools that we have to understand our reality. That's what we do. And the questions that we are asking ourselves to try to understand what the future is going to look like is, how can you improve those tools that we give to people to model the realities of their business applications? So briefly, I would like to go through these questions that we are asking ourselves. How should we create and evolve systems? How do people add knowledge? And how can we accelerate the process in terms of getting new knowledge to build new systems? So how can we create and evolve systems? As I said, this is different types of code written in different languages, all of which have to work in an orchestrated fashion to provide users with an end solution. And this is perhaps a great challenge. A couple of years ago, you could have just had a circle that said code, and that is what you had to do in the 80s. You wrote a circle that was RPG or COBOL code, and that was more than enough. Well, nowadays, what we have to do, as I was telling you, and this is something that is increasing, is you need to write code for your programs in different languages. You need to build the infrastructure, write the configuration. All of that needs to be consistent. And therefore, to us, it remains relevant to have the way in which we have to create systems having knowledge at the center. We think that with GeneXus, we are not only giving our clients a functional system, but also that we are giving them a knowledge base. We're giving them a digital asset through which they will have what we have a future-proof system, that they will be able to use that knowledge in the future, and it will adapt to other contexts, other technological contexts. So that is our road, how to add knowledge from different parts in terms of requirements, experiences, processes, KPIs, and so on and so forth. But how do we think that people are going to add knowledge to that knowledge base? At present, we have native development environments, and we are evolving that to complement it with a web development environment through which you can have new knowledge in your knowledge bases. But we think that to make progress and for the different industries and to go towards a world that will require us to write less and less code, we need to move to specific business environments, and eventually we will use new ways to bring knowledge, for example, voice modeling, that our voice will allow us to build software. In terms of how to accelerate the creation and add knowledge to these spaces, we think that we have three key points. First, that people find it much easier to acknowledge if they can have a direct manipulation of the output that they need. For example, with things such as live editing, you can modify different interfaces just by touching or tweaking the model itself. But we also want this direct manipulation on data or experiences, and also on the processes that we nowadays need. That's why we need to move more and more towards the creation of declarational languages, which will allow us to ensure the way in which people add knowledge to a knowledge base. And for that, we need to delve into three aspects. First, direct manipulation of what we actually want. So code is an indirection to what we want. So we want people to manipulate directly the outputs of their systems with things such as live editing, where you can directly manipulate the screens of how you want it to, what you want it to look like. Also, we need all our GeneXus language to move towards a declarative language, because declarative language will last longer than procedures. And finally, and I think this is one of the most important points, that AI will assist us to accelerate these processes, to create models. We've been using AI, which is symbolic, for quite a long time in GeneXus, but now in the last couple of years, we believe that that could converge with other kinds of AI to accelerate the model creation processes, such as with mechanisms such as deep learning, but especially with foundational models of artificial intelligence, models that you must have heard about, such as GPT-3 or DALL-E 2. These are foundational models that, even though they had large volumes of data, then they could be retrained with fewer data to be reused in other contexts. This is like people. You know, we train quite a lot to learn how to drive a car, and then when you're driving a tractor, you don't need to start from scratch. You will have to train a bit, but it doesn't mean that you will have to start from scratch to try to understand this new context. So these foundational models thing is being exposed by those that create it. For example, OpenAI is exposing their APIs for them to be used, and we will be exploring the world of how to use this to accelerate development in GeneXus. But there are other ways to accelerate things other than AI. For example, you have knowledge graphs, which are used by Google whenever you run a search, because it has structured entities where you understand the kind of relationships, and through that knowledge graph, you can create data models in an automated way. We have to keep on working on those models that are used by designers to bring models, but also we need to use AI, for example, such as Magnify by Globant, so that based on drafts that were made or sketches that were made by people, not necessarily designers, that these can be brought to designer tools or GeneXus itself to accelerate the development of the different interactions. And of course, you have standards and other kinds of tools that will allow us to bring knowledge at a much greater speed than before. That's why we believe that GeneXus is something that we can make it evolve. We can build a better GeneXus. We are visualizing that GeneXus nowadays generates value in record time, leveraged by knowledge. But we will keep on working on how to evolve and build a better GeneXus every year. Thank you very much.